Okay, all right. So let's go ahead and go over these questions. So we have a semicircle with a radius of 6 inches. You can draw a circle and we will only focus on the semicircle. And since we will only want the area of the semicircle, the radius is 6 inches. Okay, so how do you compute, how would you calculate this? Lou? Okay, good. So the area of a circle, it's calculated by what formula? Pi r squared, right? So then you divide by 2. I think that's pretty much common sense. Everyone should know this. My only worry about situations like this is that some of you might not be super familiar with the formulas related to a circle, like 2 pi r, pi r squared. You may not be very, very clear about those two equations. My advice is that if you see square, that's an area. You only square when you have an area. So 1/2 pi r square, which would be 1/2 pi and then 36 inches square. And that is 18 pi inches square. When you answer questions, especially in math, you would always express the exact answer, meaning that you don't round, you don't approximate. So this would be the exact answer. 18 pi inches squared would be the exact answer. If you put into a calculator and say 18 and then times pi, and then you get a decimal number, you round to 3 decimal places, that would not be exact. Okay? All right. What's the arc length of a quarter circle that has a radius of 10 inches? So how would you handle this? You have a quarter circle, and then that's a right angle. This is 10 inches. So we just want the arc length over here. So what do? You will find circumference, which is 2 pi r, and then divided by 4. Now, arc length, we will use letter S, small letter S for arc length. Do you all remember learning this back in geometry? No? Yes? Yes, no? Well, and the reason why I want to point out these questions, okay, I believe this should be part of your common sense. You're in high school right now. You should know the equation for area of a circle, circumference. And if I present to you like a semicircle situation or a quarter circle situation, I expect that you know how to divide things by 2 or divide things by 4. Now, what I would like to elaborate here is this. I would like to elaborate where this 1/2 came from. Now, of course, you will say that, well, it's semicircle, it's 1/2. What do you want? It's obvious. What I want you to see is that there's something more quantitative that will show you where the 1/2 came from. This 1/2 came from part over whole, and the whole is 360 degrees, and the part is 180 degrees. That's 180. The same goes to a quarter right here. The reason why it's a quarter is because it is part over whole, and the whole is again 360, and the part is 90 degrees. So I want you to know that when we have some examples this simple, you can leverage this and extend your understanding and say, oh, so the whole idea is just part over whole. Okay. So I'm going to hand this out. And all right, so we have two equations that we know already. We have the arc length equation, and we have the area of a sector equation. So for the arc length equation, okay, you can put a letter S right here, letter S, okay. So arc length is basically theta over 360 times 2 pi r, right? That's what you learned back in geometry. Part over whole of a circumference. And that's what you did in the example. Okay? And for the area of a sector, which we use A, of course, area of a sector, it's going to be pi over, theta over 360 degrees times pi r squared. So nothing new. Common sense. Okay? The only new thing that we have covered so far is the idea of radian, which we will now go into the radian. So can you draw a circle to illustrate your understanding of a radian? We have some empty space right here on the arc length part. So can you go ahead and draw a nice little circle? And again, show your picture of what a radian is. What is a radian? A radian is related to radian. A radian, it's related to radius. And a radian is when the arc length is also a radius long. That's one radian. And of course, that's how we developed, or we also saw the reasoning behind the circumference, right? We say the way we look at circumference, which is the length around a circle, is 2 pi times r, because we use a little string to measure, okay? And we say, hey, there are 6 point something radii around a circle. And that's actually exactly 2 pi. Now, just to make something very clear, this is an angle in radian, okay, just to make things exceptionally clear. This is an angle around a circle in radian. So if I want to transform this equation to a more generic one, I can say the arc length is actually equal to theta times radius. Okay? Theta times radius. And some people may like to say r theta, theta r theta, it's up to you. Usually textbooks, they will use r theta. Okay, so a whole circle has 2 pi radian. And so if you understand the circumference formula, which is 2 pi r, you will understand this equation. S is equal to r theta. Now, I want to share a little experience from last year. So last year I was tutoring a girl taking Precal, and we were talking about this formula, and there was a quiz afterwards. And I asked her, how did you do on the quiz? And she said, I did bad. I said, how? how can you do bad? And she said, she used this equation, but she didn't realize that the theta right here must be in radian. So I'm going to write this down. Theta in this equation, in this formula, must be in radian. That's why we have 2 pi r. So now you have 2 options. If you have degrees, you can do this part over whole, theta over 360 degrees times 2 pi r. If you have radians, then you can simply use S is equal to r theta. So at this point, your job is basically knowing how to identify an angle. Is it in degree mode or is it in radian mode? And how can you tell very easily whether it's in degree or in radian? Like for this one, is it in degree mode or radian mode? Of course, it is in degree because you see the degree symbol. What about this one? Because there's no degree. Now, do not say because you see pi. It is in radian mode because you don't see the degree symbol. Okay? Because yesterday, didn't we talk about some questions with just a number? There's no pi in it. And we said, well, if it's just a number without a degree symbol, that's a radian. So now, you can you can follow me, or you can just go ahead and calculate this. So if you want to find the arc length with the given degree measurement, so you simply do a 90 over 360 times 2 pi r. Okay, so you have a quarter times 20 pi centimeters. So you have 5 pi centimeter. Okay. Now this morning, got a student came up with a suggestion. I think it's a very good suggestion. The student asked, she said, hey, Mr. Chan, I remember 90 degrees. That's pi over 2. We talk about this, right? Pi over 2. And the student asked, can I just change this to pi over 2 and use the S equals to r theta? Well, nothing's wrong, so let's give it a shot. So r theta, and same answer. Which one do you like better? Left or right? Okay, now if you have some angles that are this nice, I think the r theta, it's a lot easier. Okay, simpler, it looks simpler. So I accept either way. Okay, as long as you show it to me like, oh yeah, the 90 degrees is the same as pi over 2, I'm happy. Okay, as long as you don't confuse when to use which equation. That's the biggest thing that I would worry. All right, over here you have the radian measure. So therefore we will go ahead and use r theta. So 7 inch, 2 pi over 5. So that's not much you can simplify. Then this is the answer. Okay, S is equal to 14 pi over 5. That's all you can do with this kind of setting. Okay. Now for the next example, we have R and S. That means you can find out the theta in radians. Now this is pretty straightforward. S is equal to r theta. So theta is equal to S over R. Okay. So what's theta? It is 1/2 radian. Now, a couple of things I want to add over here. Now, I hope you are really conceptualizing the idea of radian. I hope that when you read the information that the arc length is 18, the arc length is 9, the radius is 18, you are actively creating a picture in your head. Because if not, that's pretty sad. If you know how to create a picture in your head, then you'll be able to say that, oh yeah, this is radius. The radius is 18 centimeters. And you would also know that if the arc length is exactly 18 centimeters, then you have a radian. And what's the arc length right now? The arc length right now is 9 centimeters long. So does it make sense to have half radian? Okay. Because you know how people would make a mistake over here? Instead of having 9/18, they would do 18/9. And another thing I want to make sure that another thing I want to share with you, I've been thinking this question over the weekend, last weekend. I was like, I guess everyone here, when you take a quiz or test, you want to be right. You want to get full credit. And then somehow you make mistakes. How can top students not make mistakes and some other students would make mistakes? Because the top students, they find ways to guarantee that they can catch their mistakes. Now, I want to show you how to catch your own mistakes. But are you willing to do it? That's your choice. Create a picture. If you're taking calculus, create a picture. Okay? Do not store these information as just words and numbers. Create a picture. Create meanings of the picture. Then you know it's 1/2 radian. Okay? Right? Now, another thing that I may expect to see is that somehow students may just insert a pi over here because they see radian and they are tempted to put a pi right there. Now, there are two reasons why you don't put a pi in there. The first reason is there was never a pi to begin with. And the second reason is that if you put a pi over there, pi over 2 means 1 point what? How many? 3.14 divided by 2, it's 1.57-ish. So you're saying that there are 1.57 radians if this is the arc length. If you have a picture, you will know that that's total nonsense. So please create a picture. All right, now we did this earlier, but now how can we express the equation if it is if the theta is in radian? Now here's what I want you to write down, and I want you to see something. What's 360 degrees in radians? It is 2 pi, right? So that means I can replace 360 with 2 pi. And if you replace 360 with 2 pi, now you can cancel some terms out. You can cancel the pi. So that means the area of a sector, it's basically 1/2 theta r squared. Some people would do 1/2 r squared theta. Okay. Yes. Ooh. Okay. So Again, if you use this equation, the theta must be in radians. So yeah. The other way you can also consider is that if you put a degree right here, the degree symbol would get stuck. So your answer with a degree symbol, which is kind of weird. Why would you have a degree symbol for the area? But if you put a degree angle over here, the degree symbol will get canceled out because you have 360 degrees in the denominator. Okay, so let's just work on example A. I think example A is what it's really important. So 1/2 r squared theta, r squared theta. Okay, so 1/2 36 inches squared, and then 2 pi over 3. Now remember this, you always simplify before you multiply. You always simplify or reduce before you multiply. Do not multiply 36 and 2 and then divide it by 6. That's just a lot of work. That's not smart. Okay, the smart things to do is to reduce it at the very early stage. You look at the 2, they reduce each other. 2 divided by 2, it's 1. 36 over 3, you get 12. So what's the final answer? 12 pi inches squared. pi inches squared. Now, don't get too much discomfort because of the pi. Pi is just a number right here. Pi is just a number. So what we're saying here is the area is roughly 36, 37 inches squared. Okay. All right, now let's go ahead and look at the next question down right here. Latitude of city 1 and latitude of city 2. Okay, so you're given 2 cities in degree, minute, second mode. Now, I'm not gonna waste too much time talking about these conversions since we talked about it yesterday. I'm gonna give you the the numbers. Now, if you convert the DMS mode of the degree into a decimal, it becomes 43.3225 and 39.7075. Okay, so those two are the decimal numbers of the degree of the angles. 43.3225 and 39.7075. Let me go ahead and write this down over here. So city 2. So city 2 is 43.3225 degrees. City 1 is 39.7075 degrees. Now, why do we care about these two? Well, last time I checked, the Earth is round, it's a sphere, not flat. And so what's happening is this. So we have 2 cities at 2 different latitudes. City 2 is slightly higher than the city 1. So what you can do is to find out the arc length right here. And we gave you the radius, which is 4,000 miles. So if you can find out the little theta between these 2 cities, hey, we're good. And since we are given in degrees, and we can simply do the subtraction. So go ahead, do the subtraction, and then use the proper equation to calculate it. Let me give you 1 minute to do it. 1 minute. Okay, so the difference between the two cities should be 3.615 degrees. And then which equation would you use? Okay, because it is in degrees, we use the one with 360 degrees. Okay. So we have 3.615 degrees over 360 degrees times 2 pi radius. And what is it going to be? I think I got 252.375 miles. Okay, so in this case, pi is just a number, as I said before. The default is that pi is just a number, 3.14 ish, but you will type in the pi on the calculator. Do not type 3.14. You type in the actual pi in the calculator. Okay. All right. So how many of you are in physics right now? Okay. How many of you like physics? All right. That's well understood. I did not like physics the first couple of times I took it. I only liked physics more because I had a good teacher in high school. In here, in the country, in the States. But when I was back home, I had a physics teacher, and he was terrible. All right, now, so right here we have two kinds of velocity. If you turn to your back page, page 2, we have two kinds of velocity. We have linear velocity, which is something you have learned already since middle school. Didn't you learn about speed? How do you calculate speed? Distance over time, right? So, so for those who are in physics, what's the difference between speed and velocity? Velocity has a direction, right? So we have plus or minus. That's the biggest thing that's different between speed and velocity. Now, when we say linear velocity, it is just the regular v, which is the change of displacement over the change of time. Okay, which is very simple. If you took physics, if you are taking physics, you should know this by now. If you did not take physics yet, it's basically distance over time, but we use a very specific term. We use the word displacement to indicate the shortest distance between the starting point and the end point. Now, what about the word angular? Well, the word angular comes from the word angle. I didn't know that for a few years, so I was very puzzled until I realized that the word angular comes from the word angle. So angular velocity simply means the change of angle over change of time. The change of angle over change of time. So, so we are going to talk about different ways to describe the change of angle. It could be in degrees per some time, degrees per second, radians per second. And in this context, we also learn about the word revolution. What's the meaning of a revolution? A circle, right? 360 degrees. So a revolution could mean 360 degrees, or in radians, a revolution would be 2 pi radians. Okay. So I hope that whenever I talk about a revolution, I said 2 pi. You are not feeling uncomfortable to look at 2 pi. You understand that we're talking about 6.28. Okay, that kind of thing. So let's look at the following couple examples, or 3 examples. All right, now first, it says the tires of a bicycle have a diameter of 30 inches. And I will stop right here. Whenever you see the word diameter, you should stop. Because write down the radius. All right, write down the radius. And what I've seen so often in the past is that when students are doing tests or quizzes, when they do not write down the radius and they're scrambling for numbers to plug in, well, guess what? They put 30 into the radius. I think this is very preventable. So whenever you see diameter, go ahead, write down the radius. Okay. Rotates at a rate of 120 revolutions every 5 minutes. Oh, by the way, let me also show you the symbol for angular velocity. It's called omega. Okay, it's a little W, but we call it omega. Okay. So how many of you took physics last year? Do you remember this for circular motion? Okay. Now, one equation could be particularly useful. You may want to put it down on the top of the page, which is S is equal to R theta, which we did on the previous page. But just to write it down right here to remind yourself could be useful. Now, it says it has a angular velocity of 120 revolution every 5 minutes. 120 revolution over 5 minutes. So please find out the radians. Find out the rate in radians per minute. Now, I'm going to show you a couple ways to handle this calculation. If you know what 1 revolution is, you are more than welcome to just replace revolution with 2 pi radians. You are more than welcome to just replace 1 revolution with 2 pi radians. And then you can go ahead and simplify it. This is 24. So it'll be 48 pi radians per minute. Okay. Now, the other way to handle this calculation, use a different color. The other way to handle this calculation is this. You can have 120 revolution per 5 minutes. And then you do the old chemistry way. You can do 1 revolution is 2 pi radians. It's really the same thing. It's just a slight expression difference. And you will still get the same thing at the end. So just pick whichever one you like. As long as you know the logic behind these 2 calculations, it's all good. Okay. Now, here's another thing. When you say something per something, do me a favor. Do yourself a favor. Do not use slash. Do not use slash. Use the fraction line. Okay. It's going to help you out big time because it allows you to see which one is the numerator, which one is the denominator. And that could be crucial. Okay, for math and for your physics class. If you use a slash, then you are potentially confusing yourself that you don't know which one is in the numerator, or even worse, you don't know which one is in the denominator. Okay. All right, next up, linear velocity, okay, change of distance, which will be the arc length, okay, over time. So we have radius of 15 because the diameter is 30 inches. Now it says the rate is 3.5 revolutions per second. So find the linear speed. Now, we have the radian already. That means this is our theta, basically. How can we change our theta into arc length? Well, look at the equation we wrote earlier. If we have theta, what do we need to do to get the arc length? If we have the theta, what do we need to do to find the arc length? We need to multiply by r. Right? If you have the theta, how can you get the arc length? You get the r, multiplied by the r. So what we have an equation in physics, and you can use it here, which is the linear velocity. It's omega times r, because omega is theta over time, right? So if you do that, that's just distance over time, the arc length over time. So that's the scientific justification behind the equation, behind the formula. So you have, but be careful. The theta must be in radians, not revolution. So you will have to do some conversion before you get too excited. So we have 3.5 revolution per second, and we will have to change it to radian. And then we multiply by the radius, which is 15 inches. So there will be 7 pi radian per second times 15 inches, which gives us 105 pi inches per second. Okay. All right, now go ahead and try this one yourself. Okay, for the Ferris wheel. Okay, give you a minute to try it. The angular velocity of the wheel in radians per minute. So you have the omega at 2 revolutions per minute. Then you can simply go ahead and replace the 2 revolution with 2 pi. So that means it is rotating at 4 pi radians per minute. Right? But then what's the linear velocity? Linear velocity is omega times r. So omega, it's 4 pi radians per minute. And then times the radius, which is 20 feet. So 80 pi radian per 80 pi, I'm sorry, 80 pi feet per minute. Feet per minute. It's linear now. Okay. So as you are doing these calculations, I sincerely hope that you can see vividly how we have the r times theta right here. The r times theta, the r times theta to get you the linear distance.
20 feet from the center, what happens
20 feet from the center. Diameter is from the center, from the side to the other side. That's a diameter. Okay. All right, now let's take a quick look on the worksheet. I want you to look at question 1A. Now, if I ask you to look at this picture, and I need you to answer me very quickly, is it bigger than 1 radian or less than 1 radian? It's bigger. Is it bigger than 2 radians or less than 2 radians? Less. Okay. For this picture, is it bigger than 1 radian or less than 1 radian? How do you know? Yeah, the radius is 75, and the arc length is less than 75. Now, if you're able to quickly answer these 2 questions, I am very pleased. All right, so again, the only challenge for these guys here, it's the only challenge, it's really just knowing that the angle could be in degrees, it could be in radians, and using the proper equations, proper formula to get the right answer. That's really it. So go home and finish the worksheet. Next Monday, we will dive into the whole sine, cosine, tangent, and that will mark the journey which we will embark for the next few months. We will make good friends with sine, cosine, tangent. Oh, by the way, let me make this disclaimer. In this classroom, you say sine, cosine, tangent. You do not say sin. You do not say cos or cos. You do not say tan. Okay, if you say sin, then you are committing a sin.